Watch this. You type te and your phone swaps it to the in a flash. But autocorrect didn't peek in a dictionary. It screamed, "What the heck is te?" and still nailed it. How? Because it's a tiny word detective, not a spell-check robot. So autocorrect isn't just a dictionary. It's like a friend who knows all the words and they're best friends. When you mess up, it checks the word's neighbors to guess what you meant. Think of it as a weather forecast for words. Cloudy with a chance of the. Let's take a simple sentence. I want to eat the pizza. Now imagine you typo the fourth word and type te instead of the. Your phone sees te and thinks, which real word is this most likely to be? Here's the cool part. Your phone turns every real word into a tiny list of numbers, like a secret code. For example, the word the might become 0.2, 0.4. The word a could be 0.1, 0.3. These lists are called embeddings. Now your phone takes the typo te and turns it into its own secret code too. Even though te isn't a real word, the code ends up looking like 0.21, 0.39, super close to the. So how does the phone know te is closer to the than to a? It uses a math trick called cosine similarity. This measures how closely two secret codes point in the same direction. If the angle between them is tiny, they're best friends. Let's calculate it step by step. First, we multiply the numbers in the codes. 0.21 x 0.2 plus 0.39 x 0.4 equals 0.042 plus 0.156 equals 0.198. Then we divide by the lengths of the codes. SQRT 0.212 plus 0.392 equals 0.44 and SQRT 0.22 plus 0.42 equals 0.45, 0.198, 0.44, which is 0.45, 0.996. A cosine similarity of 0.996 means te and the are almost perfect matches. Now let's check te versus a. 0.21 to 0.1 plus 0.39 x 0.3 equals 0.021 or 0.117 equals 0.138. Divide by 0.44, it is 0.32, 0.141, so 0.138, 0.141, 0.1979. So te is way closer to the 0.996 than to a 0.979. The phone ranks all the scores and picks the highest one, the. Even though te isn't a real word, the math guesses it right. Here's the tiny piece of code that does this math. It's just a few lines, like a mini detective solving the mystery. But what if the typo changes the whole meaning? Like typing quinoa as pizza. Both are foods, so they're neighbors in the secret code space. The phone might guess wrong because pizza and quinoa are close in the code list. Fast typing can also trick autocorrect. If you type "I'm hungry" instead of hungry, the phone might guess bungry because bungry sounds closer in its secret code than hungry. The math isn't perfect, it's just making the best guess it can. So autocorrect isn't magic. It's just a tiny language model doing math. It doesn't know every typo, but it knows the neighbors of real words and picks the closest match. Behind the scenes, your phone uses a process called tokenization to break words into pieces. Even if you type te, the phone splits it into t, e, h, and looks for the closest real word. Then it uses NLP, natural language processing, to understand the context. But for autocorrect, it mostly relies on the secret code math we just saw. The closer the codes, the better the guess. Let's recap the steps. 1. You type a typo. 2. The phone turns it into a secret code. 3. It compares that code to all real words using cosine similarity. 4. It picks the word with the highest score. Boom, te becomes the. Here's the full math for te versus the. 0.21 x 0.2 plus 0.39 x 0.4. 0.44 a 0.45 is 0.198. 0.198 is 1 and 10 does. Wait, why 1 word? Because the codes are almost identical. That's why autocorrect nails it every time. So next time your phone fixes te to the, remember, it's not just a dictionary. It's a tiny word detective using secret codes and math to guess what you meant. Pretty cool, right? But what if the typo is adden instead of and? Let's see how the math works for that. The code for and might be 0.3, 0.2. The code for adn could be 0.29 and 0.19. Calculate the cosine similarity. 0.29x 0.3 plus or 0.19x 0.2. 0.35 as 0.36, 0.998. See, the math is the same for adden, and as it was for te, the. The closer the secret codes, the better the guess. Autocorrect doesn't need to know every typo. It just needs the secret codes of real words. Want to see how this same tech powers voice assistants? They use the same secret codes and math to turn your voice into text. It's all about finding the closest match. Hit subscribe so you don't miss the next episode, and tell me in the comments, what's the funniest autocorrect fail you've ever seen? Let's see if we can crack the code together.